Okay, let's move on to number 6. The first two numbers of a sequence are 2 and 6. If the sequence is arithmetic, find the next three terms, the common difference, and the explicit rule. Okay, so the first two terms are 2. Let's start by writing that. And 6. And then it's asking us to find the next three terms, assuming that the sequence is arithmetic. So if the sequence is arithmetic, that means it's changing by a common difference. So from 2 to 6, it looks like it increased by 4. So if it's arithmetic, it should be increasing by the same amount every time. So that means that the next term is going to be 10, and then plus 4 is 14, and then plus 4 is 18. There's the next three terms, 10, 14, 18. The common difference is what we just said, which is 4. And the explicit rule then, using that information, is going to be f of n equals a, which is 2, plus d, which is 4, times n minus 1. Because we will call the first term 1, position 1. There you go. That's it. The next three terms are 10, 14, and 18, and d equals 4. Now, part B, it says, if the sequence is geometric, find the next three terms, the common difference, and the explicit rule. So with the same two starting terms, 2, then 6, then another term, another term, another term. But this time they want us to assume that it's geometric. So if it's geometric, to get from 2 to 6, you don't add, you multiply, right? What did you multiply by? It looks like 3. 2 times 3 is 6. Times 3, times 3, times 3. So that's how we're going to find the next term. So 6 times 3 is 18, times 3 is 54, times 3 is 7, no, 3 times 4 is 12, 15, 162. So there's the next three terms. Find the common difference. Whoops, that's a mistake. If it's geometric, it doesn't have a common difference. It has a common ratio, right? So the common ratio is 3. Well, we found it. It's whatever number you're multiplying by. And find the explicit rule. Okay, so for a geometric sequence, it's going to look like this. F of n equals a, which is 2, times r, which is 3, to the power of n minus 1, because once again I'm calling this the first term, the second term, and so on. And there's the explicit rule. Part C, one of the terms in the sequence is 178. Is the sequence arithmetic or geometric? Okay, well, let's compare them. The arithmetic one went 2, 6, 10, 14, 18, and so on, right? The geometric one went 2, 6, but then times 3 is 18, then 54, then 162. Right? Yes, those are the numbers. And it keeps going. So this question is saying that one of the terms in the sequence, so later in the sequence, one of the terms is 178. So is it arithmetic or is it geometric? Because 178 only fits in one of these. Now, the easiest thing to do is to keep the geometric sequence going, because 178 is not that far away. So keep it going for a little while to see if you hit 178. So what's 162? Keep it going, times 3. I'm going to punch that into a calculator. And I get 486. So right away I know it's not geometric, right? One of the terms is 178. If I follow this sequence, I basically skipped 178. It's not in this sequence. It's got to be in that one. So somewhere in this sequence, somewhere later, 178 is part of the sequence. We can actually figure out exactly where by plugging in 178 into the explicit rule that we figured out earlier. We could plug in 178 into this rule right here. And see what term in the sequence it is. But we can pretty much say correctly that it's arithmetic, because 178 does not exist in the geometric sequence, right? If it did, it would be right in here, but it actually got skipped. 162 went straight to 486. Okay, number 7 is all yours. I want you guys to do exactly what I did in number 6. I'm giving you the first two terms, and then you're going to assume that it's arithmetic to find the next three terms, the common difference, and the explicit rule. Then you're going to assume that it's geometric to do the same thing, and then it's going to give you a number that is in the sequence, so you have to figure out is it arithmetic or geometric from that. Okay, so go ahead and try it on your own. If you need to, go rewind and watch my example for number 6 again. But try it on your own first, and then come back and see the final answer. Okay, go ahead and pause the video right now. Okay, so here you go. These are correct answers for number 7. In part A, it says the sequence is arithmetic, so find the next three terms. So I started with 2 and -8 like they gave me. I figured out that if it's arithmetic, it must be changing by the same common difference, which is -10. So minus 10 gives you -8, minus 10 gives you -18, minus 10 gives you -28, and so on. So that means that the common difference is -10. And so the function rule for this, the explicit rule, is 2 minus 2 because that's the initial term, minus 10, which is the common difference, times n minus 1 because we're calling it the first term for that one. In part B, if we assume that the sequence is geometric, then we don't have to find the common difference, we have to find the common ratio, right? So I started with 2 and -8. And since it's geometric now, it's not changing by the same number. It's not subtracting 10. You got to think of multiplication. So what do you multiply by to get -8? -4. 2 times -4 gives you -8. Times -4 is 32. Times -4 is -128. Times -4 is 512. Those are the next three terms. So the common ratio is -4. And the explicit rule is f of n equals 2 times -4 to the power of n minus 1 because it's a times r to the power of n minus 1, once again because I'm calling this one the first term, position 1. Part C, it says that one of the terms in the sequence is 8192, so is it arithmetic or geometric? I compared them both and I figured out that it has to be geometric. Because look at the way the geometric one is changing. It's increasing, changing signs, right? 2, -8, positive 32, -128, positive 512, -2048, and so on. So I kept it going a little bit more to get to that number 8192. So it is geometric. Also, the arithmetic one makes no sense because look at these numbers. They're getting negative, negative. They're becoming more and more negative. So if you keep it going, you're only going to keep getting negatives because you keep subtracting 10. So you're never going to get positive 8192. So the answer for this is that the sequence must be geometric. If 8192 is one of the terms in the sequence somewhere in the future, then it has to be geometric. Alright, moving on to number 8. Write the arithmetic series in summation notation. Okay, so this is arithmetic series. Summation notation, what they mean by that is this. N equals 1. Here you write the rule, and here you write the last term, or the position of the last term. So where you stop, the end, right there on top. So what I'm going to figure out first is what the rule is so that I can plug it in here. And then I'm also going to figure out how many terms total there are so that I could put that number there. And that's it. So let's start with that. Let's figure out the rule first. What I see here is that A, the initial term, is -2. And D, the common difference looks like 5. It's increasing by 5, right? -2 plus 5 is 3, plus 5 is 8. So my rule is f of n equals -2 plus 5 times n minus 1. It's arithmetic, not geometric. You're adding 5, so it's n minus 1 is in parentheses, not a power. And then what I need to figure out is how many terms there are. We also need that, right? How many total terms there are in this series. So what you do is you take this rule that you just found and plug in 53 for f of n. And that'll basically give you n, which is the number of terms. So let's plug that in. It's 53 equals -2 plus 5. You know what? I'm going to go ahead and distribute the 5 here to solve for n. 5n minus 5. -2 and -5 make -7 plus 5n equals 53. Add 7 and we get 60 equals 5n. I'm going to continue here. And finally divide by 5 and you get 12. N equals 12. that means that the last term is the 12th term. That means that there are 12 terms there. Okay, so now we're ready to write the summation notation. Sigma n equals 1. We're going to start with n equals 1 because we're using this rule. If we had just used n, we would use n equals 0 here. Okay, but we're using n equals 1. The rule is this right here. So that's what you write right next to sigma right there. You write 2 or negative 2? Negative 2 plus 5 times n minus 1. And on top you put 12 because that's how many terms there are. That's the last term on your rule. There you go. That's it. And when we're writing this, we always start with n equals 1 because it is the easiest thing to start with, because whenever we find n, that's basically the number we put up top. We could, of course, start with a different number, okay, but it would be way too complicated to try to figure out, well, if I start with 2, where should I finish? And also my rule would change at that point, okay? So we stick with 1 so that we can use this same rule, and then whatever the number of terms is, we can just put it up there. All right, let's do it again. Once again, I need to figure out the rule. So I know that A in this case, oh, not red, let's do blue. A in this case is 7. And D, the common difference, it looks like it's decreasing by 6, so minus 6. So using that, I can come up with this rule. F of n equals 7 minus 6 times n minus 1. So that's the rule I'm going to plug in into my summation notation, which is with sigma. Now what I need to figure out is n, how many terms there are. So I'm going to use negative 59 right there. Negative 59 equals 7 minus 6. I'm going to distribute the negative 6n, so negative 6n. Negative 6 times negative 1 is positive 6. 7 and 6 make 13, so 13 minus 6n equals negative 59. I'm going to subtract 13 here, and I'm going to get negative 72 equals negative 6n. Finally, divide by negative 6, and I got n to be 12. Again, I must like that number. So n equals 12. So using that, and using this rule, I can now write it in sigma in summation notation. So it looks like this. Sigma n equals 1, because we're starting our rule with n equals 1, right? The rule, which is 7 minus 6 times n minus 1. 7 minus 6 times n minus 1. And finally, the number of terms, which is 12. There you go. That's summation notation for that sequence. All right, your turn. C and D are yours. All right, so C right here, D right here. Go for it. Try them on your own. If you have to rewind and watch the ones I just did, go ahead and watch them again. It's okay. But take your time to do them on your own, then come back and check your answers. Go ahead and pause the video right now. Okay, here you go. Here is C. I came up with the rule 1 plus 2 times n minus 1 because the initial term is 1 and the common difference is plus 2. And I'm calling this one the first term, so n minus 1. Then what I did is I plugged in 103 here into f of n so that I could figure out how many terms there are. So I plugged in 103 and also I distributed the 2. So I got 2n minus 2. Then I combined the 1 and the negative 2 to make negative 1. I added the 1 and divided by 2 to get n equals 52. And that's all the work you need, because now all you got to do is just put the sigma, n equals 1, which is where we're starting, the rule, which is 1 plus 2 times n minus 1, and your final term, your final position, which is 52. For D, here's what I got. I got f of n equals negative 10 minus 4 times n minus 1. A is negative 10, the initial term. D is negative 4 because you're subtracting 4 every time. I plugged in negative 90 for f of n to figure out how many terms there are. Negative 10 and positive 4 makes negative 6. I add 6, I get negative 84. Negative 84 equals negative 4n. Divide by negative 4, and so n equals 21. And here it is, sigma with n equals 1 and 21 on top, because that's how many terms there are. and the rule that I came up with before, negative 10 minus 4 times n minus 1. Alright, let's move on to number 9. It says find the sum of the finite series. So these are very recent. We just practiced these in class very recently. Actually, we practiced some today and also on last Friday. So let's find the sum. First thing you need to do is figure out what kind of series it is, right? I told you guys, either identify it as arithmetic or geometric. And that's what basically tells you which formula you're going to use. This one, you should be able to see, is arithmetic, because it's 3n. So every time n is being multiplied by something, then it's arithmetic. I messed up there. I was about to write an I, but it's an E, so arithmetic. Also, the next thing you need to figure out is how many terms there are. And that basically is n. That's what you're going to use for n in your sum formula. How many terms there are, you find by subtracting and adding 1. This is actually the easiest form that I can give you, because you can easily find how many terms there are by just subtracting these numbers and adding 1. So 10 minus 1 is 9, plus 1 is 10. That means there are 10 terms. Okay, so we're pretty much set and ready to find the sum. What you're going to do is use this formula, S of n. This is an arithmetic series that has an n. It is a finite. So you use this formula, n over 2 times a sub 1 plus a sub n. So in order to use this formula, we need n. We just found it. We need a sub 1, which means the initial term, and a sub n, which means the final term, the last term. These two are not 1 and 10. These two numbers are what happens when you plug in 1 and then what happens when you plug in 10, right? What happens when you plug in the first number here and what happens when you plug in the last number. That's what's going to give you these two. So a sub 1 is plug in 1 right here. 3 times 1 is 3. A sub n is what happens when you plug in this number. Plug in 10 now. 3 times 10 is 30. And there you go. Just plug in those numbers into your sum formula and you're done. S of 10 is equal to 10 over 2 times 3 plus 30 equals 5 times 33. So that equals 165. There you go. The sum of these 10 terms is 165. Pretty simple. If it's arithmetic, all you got to remember is to use this formula to find the sum. This formula is used to find the total sum of the numbers. Okay, n is 10 because 10 minus 1 plus 1. A sub 1 is 3 and a sub n is 30. A sub 1 means the initial term. A sub n means the final term. 30 plus 30 is 33. 10 over 2 is 5, so 5 times 33. I'm going to let you guys do B and C on your own. So go ahead and work on those on your own, please. And pause the video as always and then come back to check your answers. So go ahead and pause the video right now. Okay, here you go. Here's the correct solutions for B and C. Both of them are arithmetic, as you can see from n is being multiplied by a number, right? N is 10 in this one because it's 12 minus 3, which is 9, plus 1 is 10. A sub 1 is negative 8. I got that by plugging in 3, right? A sub 1 means what is the initial term. Plug in 3 and I got negative 9 plus 1 is negative 8. A sub n is the final term, which is negative 35. I got that by plugging in 12. Negative 36 plus 1 is negative 35. So using those numbers, I plug them all in here into my sum formula for the arithmetic sum. And I got negative 43 in here times 5 is negative 215. For B, same thing, arithmetic. N is 15 because it's 14 minus 0, 14, plus 1, 15. A sub 1 is negative 5, which I got by plugging in 0. And A sub n is 51, which I got by plugging in 14. Plug in 14 here, and you're going to get 51. You get 56 minus 5. So then I plugged in these three numbers into my sum formula. 15 over 2 is 7.5. Negative 5 plus 51 is 46. Multiply them. You get the total sum of 345. Alright, let's move on to D. Let's do this one together. This one is not arithmetic, right? You guys can see that it's geometric. This one is geometric. I can tell because of the rule. Notice that it has a power, right? And if it has a power, that means that the base is basically r, and that means that it's geometric because n is the exponent. If n was not the exponent, it would not be geometric. All right, so let's find n. The number of terms in this one is 9 minus 1 plus 1. So 9. 9 minus 1 is 8, plus 1 is 9. Geometric sequences. Okay, before I continue, let's write down what it is that we need for a geometric sum. This is the formula that you should be using. A times 1 minus r to the power of n over 1 minus r. That is the formula for a geometric series, the sum of a geometric series. So in this formula, we need a, the initial term. We need n, how many terms we have, we already got that. And we need r, and also we have that based on looking at the rule right there. So let's write r already. We know what it is. R is 2, correct? Remember, if you can't tell, just look at the rule. Whatever the power is, look at the base. The base is r. Also, we need a. A means the initial term, okay? So that means plug in the number below, the number on the bottom. Plug it in to see what you get. Plug in 1, you get 2 to the 1 power, which is 2. So a is 2. So there you go. Plug in those three numbers into the sum formula, and you will find your final answer. So S of n, which is 9, equals a, which is 2, times 1 minus r, which is also 2, to the 9th power, all over 1 minus 2. At that point, it's calculator work. Make sure you're doing it carefully and slowly so you don't mess up. Equals 2 times 1 minus 2 in the denominator, that's negative 1. 1 minus 2 to the 9th. I think 2 to the 9th is 512, if I'm not mistaken. Let me see. Yep, 512. So 1 minus 512 in the numerator. That means 2 times negative 511 over negative 1. And so that's positive 511, right? Times 2 is 1022. There you go. That's your final sum. Once again, notice that I started first by checking if it was arithmetic or geometric. This one is geometric. Then I figured out what n was. Always the same way. 9 minus 1 plus 1, right? This number minus this number plus another number. And then I figured out, well, if it's geometric, then I need this formula. In order to use this formula, I need to know what a is and what r is. R is easy to find right there from the rule. Look for the base, which is 2. And a is the initial term, which I got by plugging in 1 right there. Take those three numbers, plug them all in. Make sure you're doing your work carefully. And I got 1022 for the total sum. All right, E is yours. Go ahead and work on that one on your own, please. Once again, like always, pause the video, then come back and check your work. So go ahead and pause it right now. Okay, here you go. Here's your final answer for E. In this one is geometric, again, because I see that there has a power where n is the exponent. I found n right away by subtracting and then adding 1. 8 minus 1 plus 1 is 8. I found r because I looked at the power. The base of the power is r. And a is the initial term, which I got by plugging in 1. Plug in 1, you get 3 times negative 2 is negative 6. Using those three terms, those three numbers, I plug them all into the sum formula for a geometric series that is finite, right? It has an ending, so this is the one we use for finite geometric series. So a is negative 6, r is 3, n is 8, and then after that, again, calculator work. You gotta be careful, make sure you're doing it carefully. 1 minus 3 to the 8th is negative 6560, divided by negative 2 times negative 6. This is positive 3280. Times negative 6 is negative 19,680 is the total sum. Alright, number 10. It says determine if the series converges or diverges. Basically, for these problems, guys, you got to make sure that it's geometric because we're going to be looking for r. And also the basic idea is, are the numbers getting bigger or smaller? If they're getting bigger, it diverges. If they're getting smaller, it's going to converge to a single number, right? So let's find r. In A, let's look at A. Negative 3 plus 9 minus 27. Can you guys see r? To get from one term to the next, it looks like I'm multiplying times negative 3, right? Negative 3 times negative 3 gives you 9. Times negative 3 again gives you negative 27, and so on. So r is negative 3. That means that this is going to diverge. Remember, because I told you guys, check the absolute value of r, which is 3. If that number is bigger than 1, then it diverges. If that number is less than 1, then it converges. So this one will diverge. It diverges. So look at B. 18 plus 9 plus 4.5 plus ... 18 plus 9, that looks like it's exactly half. So it looks like we're multiplying times 1/2. Times 1/2 gives you 9. Times 1/2 again gives you 4.5. So r is 1/2. That is a number that is smaller than 1. So this one will converge. It converges. So notice how if r is a small number, meaning smaller than 1, it converges. If r is a big number, meaning bigger than 1, it diverges. And you can tell by looking at the numbers. Look how they are getting smaller and smaller and smaller. But in the other one, yes, they're changing signs, but they're getting bigger, right? 3, 9, 27, and so on. All right, C and D are yours. Go ahead and try C and D on your own. Pause the video right now and then come back and check your answers. Okay, here you go. These are the correct answers for C and D. In C, it looks like you're multiplying by 1/3, right? The numbers are getting smaller by 1/3. So 18 times 1/3 is 6, times 1/3 is 2, and so on. That means that r is 1/3, which means that it converges because this is a small number. Smaller than 1 converges. In D, it looks like they're getting bigger by 4. You're multiplying times 4, and so on. So r equals 4. That means that it diverges because that's a number that is bigger than 1. All right, number 11. Find the sum of the infinite series. We only have one formula for infinite series, and it looks like this. S equals a sub 1 over 1 minus r. Where a sub 1 represents the initial term, r represents the common ratio, the constant ratio. So remember that I told you guys you can only use this formula if it meets 3 requirements. 1, it has to be geometric. This one is geometric. Notice the n power there. 2, it has to be infinite. There it is, infinity. And 3, it has to converge. This one does converge because r is 1/2, which is a small number. So it meets all 3 requirements. That means we use this formula. So in order to use this formula, we need the initial term and we need r. Let's find those two. The initial term and r. The initial term comes from plugging in whatever the initial number is down here. So plug in 1. When you plug in 1 right here, you get 1/2 to the 1 power, which is 1/2, times 3, you get 3/2. R is the base of your power, which is 1/2. So plug in those numbers. S equals a sub 1, which is 3/2, over 1 minus 1/2, right? 1 minus r. Let's keep that going. 3/2 over 1, take away 1/2 is 1/2. That means 3/2 divided by 1/2. Which we can't do. We know how to multiply, so it's 3/2 times 2 over 1. And then you multiply straight across. Oh, actually, we can cancel the 2's. And again, remember, why is it 2 over 1? Because when you divide by a fraction, that means multiply times the reciprocal. The reciprocal of 1/2 is 2. These cancel, so it's just 3. 3 over 1, which is just 3. So the sum of this series... Something went wrong here. No, never mind. Everything looks correct. So the total sum is going to be 3 for that one. That's correct. Alright, I'm going to let you guys practice on B and C. So those two are you guys on your own. Go ahead and try them on your own, please. Well, as always, pause the video right now. Do your work. If you need to, go back and watch the one I just did. And then come back and check your answer. Alright, so here you go. These are the correct answers for B and C. In B, a sub 1 is 2/3. I got that by plugging in right here. So it's 1/3 to the 1 power times 2. So 2 times 1/3, which is 2/3. R is the base, which is 1/3. I plug those into my formula, which is 2/3 over 1 minus 1/3. So it's 2/3 over 1, take away 1/3 is 2/3, because 1 is 3/3, right? 3/3 minus 1/3 is 2/3. And then what happens when you're dividing 2/3 over 2/3 is you get 1, right? If you have the same number in the numerator as you do in the denominator, you get 1. Or you could also think of it this way as 2/3 times the reciprocal of this, which is 3/2, and everything cancels, leaving you with just 1. In C, a sub 1 is 2, because I plugged in 1 right here, and I got 2/3 times 3, I just got 2 because the 3's canceled. R is the base, which is 2/3. Plug it all in into the formula. A sub 1 is 2, 1 minus R, which is 2/3. 1 is 3/3, so 3/3 minus 2/3 is 1/3. So it's 2 divided by 1/3. So what I did is I changed this to the reciprocal, which is 3, and I multiplied. 2 times 3 over 1, which gave me 6. That's your final answer. Alright guys, last couple of problems. Number 12, factor the polynomial over the integers. So when it says over the integers, that means factor, but no imaginary roots, no imaginary zeros, okay? So what you should notice, what you look for is any of the patterns that we have learned. Like this one is the difference of two perfect cubes, right? You guys see how 27 is a perfect cube? So yeah, this is an old problem. What I'm going to do is I'm going to write them both as perfect cubes. This is x cubed minus 27 is 3 cubed, right? So I showed you guys how to write those. And then use that to fill up your pattern. Remember what I said? Basically, you write them both as cubes, and then you take whatever the bases are. So it's x minus 3, like that. Once you have that, you're pretty much done, because to fill in these, all you got to do is, remember, for the first term, square this one. Square the first term, x squared. For the middle term, you multiply them by each other and change the sign. So x times negative 3 is negative 3x, but change it to positive. So plus 3x. And for the final term, you square the final number. And it's going to be positive because no matter what, when you square it, it's always going to be positive. So negative 3 times negative 3 is positive 9, plus 9. And that's it. You cannot factor anymore, because this trinomial, even if you try, you cannot factor anymore. You can try to find the roots using the quadratic formula, but as always, you're going to get imaginary solutions, and it says factor over the integers only. No imaginaries, no complex numbers. That's your final answer there. Let's do it again. B, 5x to the fourth plus 40x. The first thing you got to notice there is that they have something in common to factor out. So factor out the GCF. They both are divisible by 5, and also they both have x. So factor out 5x. When you factor out 5x, for the first one, all you have is x cubed. In the other one, you have 8x. No, not 8x, just 8, because when you divide by x, it cancels out. And then what you should notice is that this is a sum of perfect cubes. So I'm going to, for now, ignore the 5x. Just save it for later. You know what? I'm going to circle there to remember it for later. But just continue working with this. So that is x cubed plus 2 cubed, right? 8 is a perfect cube. And then you see that those are perfect cubes, so you can follow the same pattern that we did before. It's x plus 2, right? X because of that one, 2 because of that one. No more cubes. You just want the basis of that. And then to find these, all you care about is these numbers now. This doesn't matter anymore. It's this. To find this one, square this one. The middle term comes from multiplying them times each other and changing the sign. The final term comes from squaring the other one. So the first term is x squared. The middle term is going to be negative because this one's positive in the middle, so it should be negative. 2 times x is 2x, negative 2x. And the final one is 4 because 2 squared. And let's not forget the 5x that is in front that we circled earlier. And that is your final factored form. Alright, C and D are for you guys, so go ahead and work on C and D on your own. As always, pause the video, work it on your own, then come back and check your answer. Okay, here you go. These are the correct answers for C and D. In C, I noticed first that I've had to factor out the GCF, so I factor out 4x squared because that's what they have in common, right? They both have 4, they both have x squared. Then I was left with x cubed minus 1, and at that point I noticed that they are perfect cubes. So the difference of two perfect cubes, I wrote 1 as 1 cubed, right? This one's sometimes tricky because people don't realize that it is a perfect cube. It's 1 times 1 times 1. So then, once I wrote them as perfect cubes, all I care about are the bases, which is x minus 1. That goes here. To get this one, the first term is the first term squared, x squared. The middle is times each other by change the sign. So x times negative 1 is negative 1, negative 1x. Change the sign so it's plus x. The final term is just plus 1. And 4x squared is what's left in front. Let's not forget to always write it there at the end. For D, same idea. I started by factoring out negative 3x. Okay, I factor out negative 3x because they both are negative, so I wanted to turn it positive. You really don't have to do that step, but it's always better to factor out the negative so you don't have to be worried about it. And when I factor out negative 3x, I got x cubed plus 64 positive because negative divided by negative is positive. So that means that I have perfect cubes inside. 64 is 4 cubed. So then I wrote just the basis, x plus 4. And then square the first one, x squared, times each other, but change the sign, so negative 4x. Square the last one, 16. And then in the front, don't forget to include that term, negative 3x. And that's your final answer. Alright, we made it to the last ones, guys. So number 13, write the polynomial function with real number coefficients with the least degree that has the zeros given. Okay, so they want us to write the polynomial function that when we solve it, it has these zeros right here. So let's go ahead and get started with A already. So the zeros they gave me are 3i and 2. As we learned before, something's missing here, right? Every time you have an imaginary or a radical zero, there must be a conjugate to it. So 3i has a partner, which is negative 3i, right? This one right here cannot be by itself. It needs the partner, which is negative 3i. 2 is just 2. It does not need the partner of negative 2. Okay, it's only for imaginaries or radicals. Any of those, you need to include the conjugate. So you actually have 3 zeros. So what you're going to do is you're going to set 3 sets of parentheses, one for each one. Always x minus, right? So x minus 3i. And x minus negative 3i, which is actually going to make it x plus 3i, and x minus 2. Those are the ones you need to multiply. And at this point, it's just multiply them all times each other. So I'm going to start with these two right here. Multiply those two first. So here we go. X times x, x squared. X times 3i is 3ix. Like that. Now let's do the negative 3i times x. That is negative 3ix. And finally the negative 3i times the positive 3i. Negative times positive will be negative. 3 times 3 is 9. I times I is I squared. Let's continue with that before we multiply by x minus 2. Here what's going to happen is the 3ix and the negative 3ix will cancel, so it's just x squared. Minus 9, and remember I kept telling you guys, think of I squared as negative 1, because that's what it is. I is defined as the square root of negative 1, so I squared is negative 1. So what you have is negative 9 times negative 1 right there. That's what that is. Which really means x squared plus 9. Right? Negative 9 times negative 1 is positive 9. And you need to multiply that times x minus 2. By the way, this is a common mistake. You guys will get hung up on this, and you'll get up to this, and you'll circle it, and you say that's your final answer, and you forget about the other one over there. Alright, so now we got to just multiply x squared plus 9 times x minus 2. That's x cubed. X squared times negative 2 is negative 2x squared. 9 times x is 9x. And 9 times negative 2 is negative 18. It looks like we're done. I was going to say let's combine like terms, but there are no like terms here, right? So that is it. And it's already in standard form too. So that's your final answer. X cubed minus 2x squared plus 9x minus 18. Alright, let's do the next one, which is part B. What you should do first on this one, guys, is I wrote it incorrectly. It's still correct, but you should never write an imaginary number or complex number where you write the imaginary part first and then the real part, right? We write negative 3, which is the real part, plus 2i, which is the imaginary part afterwards. The difference is that when I try to find the conjugate of this, the conjugate of negative 3 plus 2i will be negative 3 minus 2i, correct? Right? The conjugate is keep the real part the same, change the imaginary part. And that, when I multiply them out, that would work out because they will cancel. If I leave it like this, you're going to think that the conjugate is 2i plus 3, which is not correct. I mean, it is the conjugate, but it would not cancel. So you want to write it like this, so that the imaginary part is the one that changes the sign. The real part, the negative 3, stays the same. Okay, so basically I already gave you guys what you're going to do. You're going to take the initial, this is not two separate numbers. This is 2i minus 3 connected as one complex number. The conjugate of it is negative 3 minus 2i, because this is negative 3 plus 2i. And then this is the negative 3 by itself. So there's 3 zeros on this one too. And you're going to use those 3 zeros to write x minus, x minus, x minus, like that. Now, since these have two parts to them, I'm going to plug them in here, but I'm going to put parentheses for them so that I don't mess up. This one does not have separate parts. It's just negative 3, so I can just basically plug that one in. It's x minus negative 3 for that one, just like that. But the other one is going to be x minus negative 3 plus 2i, negative 3 minus 2i. Alright, let's finish it. What you're going to do here is basically distribute the negative. It's minus negative 3, so that means plus 3, and minus 2i. So what you have on this one is x plus 3 minus 2i. Same thing for the next one. Distribute the negative, and you're going to get x plus 3 plus 2i. And then the other one is just x minus negative 3, which is x plus 3. The first thing you're going to do is multiply these, the ones that have the imaginary number in it. So let's multiply those out. You're going to do x times x, then x times 3, then x times 2i. Let's do those first. That's x squared plus 3x plus 2ix. Next, I'm going to do 3 times x, and 3 times 3, and 3 times 2i. So for that, I'm going to get plus 3x, plus 9, and plus 6i. And finally, I'm going to do the 2i. Negative 2i times x, negative 2i times 3, negative 2i times positive 2i. So negative 2i times x is negative 2ix. Negative 2i times 3 is negative 6i. And negative 2i times positive 2i is negative 4i squared. Alright, combine like terms and cancel as much as possible. 3x and 3x makes 6x, so it's x squared, right? That one doesn't combine with anything. So that one's done. 3x combines with 3x, and that's it. So 6x for those two. 2ix and negative 2ix cancel. Also 6i and negative 6i cancel. So then what you have left is 9. Let's do it in blue, since that's what the color I'm using right now. And negative 4i squared. Remember, every time you guys see I squared, you think negative 1. So that's negative 4 times negative 1, which is plus 4. So you have x squared plus 6x plus 9 plus 4. 9 and 4 make 13, so you have x squared plus 6x plus 13. You're not done. This is a common mistake. you guys will get hung up on this part, multiplying these, that you forget about this one. We still have an x plus 3 here that we haven't multiplied out. So let's multiply the x plus 3. Actually, I'm going to write it in front. So I'm going to write x plus 3 times x squared plus 6x plus 13. I just like the smaller polynomial to be first, because then I can just distribute those two numbers. So I'm going to multiply the x times those 3, and I'm going to multiply the 3 times those 3. Alright, so for the x times x squared is x cubed, x times 6x is 6x squared, x times 13 is 13x. For the 3 times x is 3x squared, 3 times 6x is 18x, and 3 times 13 is 39. And now combine like terms and finish it. So it's going to be x cubed, there's nothing to combine it with. Then 6x squared and 3x squared make 9x squared, plus 9x squared. Then 13x and 18x add up to 31x. And finally 39. And there is your polynomial. So C and D are going to be yours, but remember the basic idea is to start your three binomials, which is x minus, x minus, x minus, whatever numbers they gave you. Don't forget about the conjugates. If they give you 3i, then you need the opposite. If they give you 2i minus 3, which is really negative 3 plus 2i, then you need the conjugate, which is negative 3 minus 2i. Just a quick hint, in D, it's also backwards. You should not write it as 5i plus 1. You should write it as 1 plus 5i. And then you can find the conjugate of it. Alright, so go ahead, do C and D on your own, and come back and check your work. Go ahead and pause the video right now. Alright guys, here you go. These are the correct answers for C and D. In C, it's 4i and negative 5, but you need to include the conjugate of 4i, which is negative 4i. So my factors are x minus 4i, x plus 4i, and x plus 5. Right? Remember, because it's always x minus, but when you plug in the negative 5, it's x plus 5. I multiply these two, and the 4ix and the negative 4ix canceled out. Negative 16i squared, don't forget, I squared just means negative 1, so it's negative 16 times negative 1, which is plus 16. X squared plus 16 times the x plus 5, let's not forget about that one. You multiply that out, and that's your final answer right there, as when you distribute. X cubed plus 5x squared plus 16x plus 80. In D, I told you guys to switch the 5i plus 1 as 1 plus 5i, because the conjugate of 1 plus 5i is 1 minus 5i. So there's 3 zeros, 1 plus 5i, 1 minus 5i, and 4. So I made 3 sets of parentheses for each factor, x minus, x minus, x minus, and all of them. And when I plug these in, I put them in parentheses to make sure that I don't mess up, because I need to distribute the negative. So 1 plus 5i goes in here, which means x minus 1 minus 5i. 1 minus 5i goes in here, which means x minus 1 plus 5i. And the final one is x minus 4, because when you plug in 4 into x minus, you get x minus 4. Then I multiply these two, and this is the longest piece of work you're going to do. Distribute everything. Distribute the x, distribute the negative 1, distribute the negative 5i. I got this, in which 5ix and negative 5ix cancel. Also 5i and negative 5i cancel. And the negative x and the negative x together make negative 2x. Also I have a 1 here, and negative 25i squared, which is negative 1, so it's negative 25 times negative 1. That means negative 25 times negative 1 is positive 25. So this is 1 plus 25, which is 26. That's how I got 26 right there. And finally, not forget the x minus 4 that you still need to multiply by. So what I did is I flipped them around to put the x minus 4 first, just because I like to distribute the one with the shortest amount of terms. Distribute the x, distribute the negative 4. I got this. In this case, I got x cubed for the first one. I got negative 2x squared and negative 4x squared, which I combined together to make negative 6x squared. And then 26x and 8x make 34x. and then 104. And that's your final answer. Alright, and that concludes the video review for continue studying, continue reviewing, because the test is coming up very soon. See you guys tomorrow.